Okay, and I'm sharing my screen. Okay, so before we start, um, let's see. Let's check yesterday's class. Okay, so yeah, what is fault tolerance? Can anyone let me know what is fault tolerance in HDFS or Google Drive? How fault tolerance is managed by HFS and HFS? Anyone? Anusha, Deepti, Veda, Arun, Karthik. What is fault tolerance?
Sir, it will actually
Data
continually
is
flowing.
Sorry.
It like it makes sure that even the system
Hmm.
continues to function, sir. Even when like no data or anything fails, services fails, something like that.
It will continue the system to function even though some system got failed. Okay.
Yes, serves to fail. Yes.
Okay. That means it will make sure that fault tolerance by replicating the data into. So whenever someone asks you with the fault tolerance set, that means the data should never get lost, right?
Ah,
Then
yes,
how
yes.
it makes sure that the data will never get lost? How it will make sure that? How HFS will make sure that?
data is automatically
Hmm. Automatically.
replicated.
Exactly. Yeah. So that's how it maintains the fault tolerance. It automatically replicated into different nodes, different servers, right? And in that way, it is making sure that the system is fault tolerance. That means the data will never get lost. Yesterday, someone asked the question, "What if data get lost?" So that's why this Google Drive and this HDFS make sure that data should never get lost. So that's why they will put this data into different servers somewhere around the world. So in that way, it is making sure that data will never get lost. Okay. So what is data locality?
Uh, Processes data
Hmm.
near the node.
Near the node. Exactly. Yeah. Yeah. So the data should be needed to the processing system, right? So if you want to access the data should be near to you. So if you want to process the data should be near to you. Fine. Now just tell me what is name node and data node. What are their responsibilities or functions? You name it. So just tell me.
Name node is a master node.
Hmm. Yeah.
The the data
Name node
Hmm.
split
keeps
the
track of
So
where
name node
data.
is the master node, sir, where
Yes.
it will be the main central authority, sir. Actually,
Okay.
where it will manage all the files, sir.
Hmm.
Like metadata also you can take.
Yes. Yes.
And in data node, it is nothing but a slave node, sir, where
Yes.
it is actually responsible, like given work, so splitting of the work will be given over there,
Yes.
and it can also retrieve the data as well there.
Okay.
That's also.
It can also store the data. Data node can
Ah,
also
yes, I
store the
can also
data.
store the data.
That's the main functionality. Yeah. Store the
Yes,
data.
sir.
Fine. Cool. What is the difference between secondary name node and standby name node? What is secondary name node? What is standby name node?
standby name
This
node is
secondary name node is nothing but it is like a assistant or a helper of a primary name node, sir,
Yes. Yes. What
or
it will do?
assistant.
How it will assist the name node? Primary name node.
Um, Actually, active name node does the real work.
Hmm.
So
Yeah.
standby name node stays updated along with the active name node.
Yes.
So
Yes.
with the same metadata,
Hmm.
um, like ready to overtake if active
Hmm.
fails.
Yes. Active files, standby name node will take over. Okay.
name node is metadata synchronization.
Sorry, Karthik.
Name node, standby name node metadata synchronization.
Standby name node. Metadata.
Synchronization.
Synchronization. Yeah, yeah. It will always sync with the in sync with the primary name node. In that way, it makes sure that whenever this main name node fails, right, then it will automatically take out. And how it will take out? I mentioned a name, right, a keeper name. So he will take care of this. Who needs to take out that kind of thing, right? So who? What was that name? Should I show you a diagram? I told you that he is the authority. He will decide who to take over, right? If you remember.
Zookeeper, sir.
Yeah, exactly. Zookeeper.
Yes.
Zookeeper will keeps on monitoring the health of this secondary name node, sorry, active name node and standby name node. And if someone, if that health is not good, if some issue happen, then this it will let this standby name node to take over. Okay, fine,
Yes.
fine. Hope you are following the classes good. Uh, yeah. Subhash, you have anything?
Yes, yes. Can anyone tell me what is the difference between MapReduce and SDFS?
Large data sets into a smaller parts and process them in a parallel using the map functions to produce the key values pairs and all.
Could you please speak loudly? I did not get you.
Yeah, you can hear me now.
Yes, yes, I can hear you now.
Yeah, map reduce it splits large data sets into smaller parts and it processes them in a parallel way using the map function.
Okay. So is MapReduce contains or stores any data?
Yes. No, it splits into the data sets.
But actual does it stores the actual data inside it?
No, it will be just stored in HDFS, ma'am.
Okay, good. Okay. So Ravi, you can go ahead.
Yeah, yeah. Actually, data will never be stored in MapReduce. MapReduce is kind of a processing layer. I
Program.
told
It's a
you the
program.
Yes, sir,
yeah,
yes.
I told you the architecture, right? HDFS is
Yes, yes.
storage component of Hadoop. MapReduce is processing component of Hadoop, and AN is resource manager in Hadoop, resource managing component in Hadoop. Okay,
Yes.
just remember that. Yeah, fine.
So Ravi, tomorrow the class will start at 8:15.
Yeah, I'm planning to start at 8:15 only.
Okay. So now I'm disconnecting. Actually, I have some work, so I'm leaving
Okay,
today. Yeah?
sure,
Okay.
sure, sure. Yeah,
Okay. Any issue, please ping me in the
yeah,
WhatsApp.
sure, sure,
Okay.
sure, sure.
Thank
Thank you,
you.
thank you.
Thank you, Ravi. Thank you.
Okay, team. Um, let's start today's class. So hope you guys are following very well. So just go through this document. I just recommend you to just go through this document. Why? Because I'm saying so many things, right? So many new terms to you guys, right? So I'm just going a very slow place. Actually, if you are as per the schedule, we are supposed to complete this Hadoop class by now, but actually I'm going in very slow pace, and this whole ppt pdf in one day and this pdf in one day, but I'm going in very slow pace so that you guys will understand the concepts very well. Okay, so after the class, just make sure you go through these concepts once again. Okay, in that way you will just refresh what I said in the class, and you will just try to connect the dots. You might have had something, but you are unable to connect with the actual subject, right? So just you will make those connections. Just try to go through this document again, just half an hour, that's it. Just read that out, that's it. You will understand because it's that good this document is. Okay, just follow those things, it will definitely help you in your future. Okay.
Okay, sir.
Fine, fine. And one more thing, like is it possible for you guys to join morning classes by any chance? I'm just asking.
Yes, sir.
Okay, so
Yes.
let's go one
Yes.
by one. Let's go one by one. um,
What time?
like you can suggest whether are you okay with morning classes? What was the time if you see?
The thing is, I have work from 9 to 4:30,
9 to 4:30. Okay.
but I have traveling for around 1 hour for my work.
Okay, okay. So if needed, then I mean, if you are okay, then only we'll plan. If all of you are okay, then only we will plan. But yeah, just that from 8. Maybe you need to wake up and right. So is 7 to 8 fine for you? Sorry, it won't be right because you need to travel from 8 to 9.
Yeah.
Okay, 7 to 8 not possible. Okay, let's see. Let's see. Arun, yours. Arun, you are on mute. Yeah,
Yeah, it's okay.
yeah. At what time? Morning 7 to 8 or something.
Yes, sir.
Okay, okay. Karthik.
Yes, sir. Anytime is fine. I'm available.
Okay, fine. Deepthi.
Yeah, completely fine for me till 10:30.
Cool, cool. Anusha.
10:30. Yeah.
Yes, I'm fine with it, but in rare cases, have to go for my college, sir.
Acha, acha. You are in your final year or
Yes, final year. I'm just doing my project work at home only. If they're calling me, I'll be going, sir.
okay, very rare.
Yes, sir.
Okay, seems only Veda. So accordingly, Veda we need to adjust. And Veda, you will be traveling from 8, right? And we,
Yeah.
from 7, you have some chores and you need to take care of that.
Okay.
Um,
7th till 7th, like from 7:30 I won't be able to join.
7:30. Okay, okay. Why? Because I will be honest. So this night, the night classes, right? So actually, I have some work, and you guys, I mean, you guys are waiting for me. Sometimes I'm doing it at 8:15, but sometimes I'm doing it 9:30, right? So it's getting delayed. Like you guys see, right? Before day before yesterday class, it got delayed. So if you're joining classes at that time, you will be exhausted mostly. So that's why you don't get the concepts, new concepts. Going forward, you will have more new concepts, so because of that you won't get that. But whether is it possible for you, like just 1 hour in the morning?
What time to what time though?
Yeah, you can suggest maybe 6:30 to 7:30, 6:45 to 7:45, something. It's yours choice. Just
Um,
no, because I was telling you, because it's a fresh, right? You stay fresh, and this data engineering, there is lot of things to learn, and we need to go step by step, and you need to be in that frame of mind so that you will grab this information very well. uh, that's the thing I was thinking. Because geez, I'll tell you honestly, so if now also, if I go and learn something new, I won't do it in the night. I'll definitely go and do it in the morning. So that's why I wanted to have the class in the morning. But yeah, think of that and just let me know, then accordingly we will plan. As rest of all also okay. So yeah, just let me know because everyone matters here. So that's why. Okay. You
okay, sir.
how
Let
will
you
you
know.
travel? How will you travel to your work?
By scooty.
Oh, okay, okay. Then you can't even listen to the class. Okay, okay,
Yeah.
cool. Yeah, just think and let me know. So it's up to you. If you say yes, then we will have the classes in the morning. Otherwise, we will have in the night. But night, right? Sometimes I have work with some so much of work, right? In those days, then it will be bit. I need to postpone the class to till 9:30, like a day before yesterday. So in those cases, it will be difficult for you guys as well, right? So that's what's the thing. Just let me know. Just 1 hour in the morning. You can just let me know the timing. Then that will be really good.
Okay,
Okay,
sir. I'll
it will
let
be
you know,
really
sir.
helpful for me. In fact,
Yeah, yeah. I will let you know, sir, soon.
yeah. Please, 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 please. Yeah. Thank you all. Thank you guys. Thank you for your options. Yeah, let's start today's class. Right now, we will. These are the two more steps left in HDFS. Okay, reading and writing. Okay, how read and write happens here. Okay, let's see so how read and write happens. Let's say how will this servers, right, this HFS system or Google Drive, how they will provide is they will provide some server, some interface or some system. Keep it simple. Let's keep it simple. How do you upload your file into Google Drive? You will open the app, you will put the file there, that's it. Then rest of the thing will be taken care by the Google systems, right? Similarly in hdfs, they will provide some interface or some client mission or something. All you need to do is just connect to that client mission, and how you will connect is they will give you some details or some details, password, username, password, something like that. So how you will log into any website, right? So something. So accordingly they will give the credentials or whatever maybe. So you will just connect to those client, hdfs client. Okay, this is the client node. Okay, this client node will directly connect to the name node. Okay, it will connect to the name node, and how this connection happens is simple, like they will provide some interface or some details, connection details, username, password, something like that. They'll give you just some details because you cannot log into your Google Drive without username and password, right? They'll give you those details. You will create those details, in fact, right? Then you will make a write request to name node. Okay, how you will make the request? What happens here is you will just give the file. Okay, so this file, right, this you just wanted to upload some file. That file you will go and give it to the name node. Hey name node, I want to upload this entire file into the system, this file node. Okay. Okay, how it will do is, how it will upload this file is, whenever name node gets any file. I told you many examples, right? Whenever name node gets any file, based on its block size based on its block size, it will divide that file into number of blocks, right? So for clear, whenever I give 1 GB file, this client, right, HDFS client, just gave write request to name node saying that, hey name node, just take this file and upload it Google Drive. Then what name node will do? Name node will take that 1 GB of file and divide into blocks. On what basis that blocks are created? Can anyone let me know? Blocks. How blocks are created? Yesterday we discussed that. How many number of blocks for um,
128 or 2.
yeah, exactly, 128 MB block, right? This 1 GB file you are asking name node to upload. Name node will upload. Name node will do is, it will take your file and it will create a blocks out of that file. Then for this 1 GB of file, you will have 8 blocks, right? We yesterday we discussed 1024 MB by 128 MB is equal to 8 blocks. Fine, perfectly fine. 8 blocks. Now now these 8 blocks, right, it will give this client, right, it will give this to this client. Okay, hey client, these are the IP addresses of the data nodes 1, data node 4, and data node 6. What it will do is, name node will decide where these blocks should go and sit. Okay, now because you had taken, let's say you had taken this simple, let's keep it simple, let's keep it very simple. You just give 1 GB of file for name node. Hey name node, I want to upload this file into your system. Fine. What name node will do is, name node will take this file and divide it into blocks. Fine. Number of blocks, you have eight blocks. Now these 8 blocks, right, what name node will give to this client is, hey client, these are the addresses, these are my data node addresses where you can go and write your data. Okay, now this client, right, this client will go to that address. Okay, go to that address and store the data node 1. Let's consider only block A. Okay, just keep it simple. Only block A, 128 MB file. This 128 file, I'm giving write request to block A. I need to write this block A into your system. Now it understand that, okay, there is only one block. I need to create, I need to store this block. Okay, how I need to store? Because as we discussed earlier, there is a replication factor. How replication factor? Replication factor is equal to 3. Okay, replication factor is equal to 3. Fine. Now this name node will give IP addresses of your data nodes. Now this client node, right, it needs to go to that ID addresses. Okay, data node 1. Okay, it will write the data block A into this data node 1. Okay, then from here, not from here, now from here it will take this and it will duplicate into this data node 4. Okay, now from here data node 4 it will do into data node 6. Fine. Now if the data node writing is completed, then it will go back and tell to client that, hey, your files are successfully written into data nodes. Now data node will tell to name node, hey, my run is successful, my data is stored successfully, just please note those metadata. Then this name node will store that metadata because where these blocks are stored. That's it. Okay, now let's see how this happens. Step 1, write request of block A. Name node will accept that request. Now name node as already maintains metadata of these data nodes, where data is stored, which data node is empty, which data node is already full, all those details, metadata, and all maintains all the data of these data nodes, right? Now it will give the IP address of the data nodes, 3 data nodes, because we need to have 3 replication factor. If let's say you have got 6 blocks here, it will give 6 addresses, 6 IP addresses. It could be in the same data node or different data node, but it will give 6 IP addresses. It will take the 6 IP addresses, okay, and it will ask client, hey client, just go and dump dump your data there. Now this client will go into those IP addresses, okay, and dump the data block one here, and then from here this client again fetch the data here and put it into data node 4. Step 5. See, step 1, accept the request. Step 2, give the IP addresses. Step 3, the client will go to core switch. Core switch in the sense like this servers, right? I mentioned yesterday, all the servers data will be maintained, like because the servers are in different parts of the world. Someone needs to maintain where which server is hosted in which place. Some addresses, right? That addresses in maintained here this core switch. Okay. Now this will go to core switch. Core switch will tell where is this IP addresses, how you can and route to this IP addresses, how can you go to this IP addresses. Then it will go to this IP address. Step 4, it will write the data here. Now it will come and it will write data into this data node 4. Okay. Now it will step 5 is completed. Now step 6 is this data node 4. I need to take my block A and put it into data node 6. Okay. Then once this is complete, I will go and tell my client, okay, this is complete. Fine. Now the client will go and tell name node, hey, my write request is successful. Now name node will update its IP addresses. That okay, this block A is stored in DNA1, DNA4, DNA6. You can ask me, name node only gave these addresses. Why it is updating only after client confirming? Because name node just gave this, they told this block A to store your data here, but it's not yet stored, right? If there is any issue happen in between, any issue happen, then the data is not stored in that data node, right? In that way, this name node is making sure that only client confirms I will store this metadata, otherwise I will never store this data. If somehow this data is stored here but client unable to confirm, that name node will never store the metadata where this block is stored. Client should confirm it, hey, my block is successfully written into the target data nodes. Okay, then only it will happen. Okay, so far clear? Any doubts? Or just let me know what you understand, that's it. Then we'll see, we will go to this step. Let's today, this is most important concept. Okay, so that's why I just wanted to make you understand. Okay, just try to respond. Okay, just let me know, did you understand this concept or not, right?
Yes, sir. Yes.
Just let me know one by one. I want everyone to repeat this concept, how this happens. Just Karthik, you want to go first, how this is happening, how this request is happening, how these things are happening here.
Actually, if clients write request to the block,
Okay.
uh, that name
Actually, there is some noise, Karthik, from your side, and your voice is also very low. Yeah. Well, Karthik, sort that out. Can anyone want to go next? No problem. If you say something wrong, I will correct you. Okay. Just speak up. That's it. What you understand, that's it. In that way, I will make sure that if you do not understand this properly, then I will again tell this concept, how request is made, how it was written into these data notes, all these things. Come on.
So
Yeah.
firstly in HDFS client, the
Mm.
first it will actually create, sir.
It will
Once after
actually. Okay.
create, once
Create.
after creating, it will be moving on to the distributed file system, sir.
Okay.
Once after creating that, it will move on to the name node.
Name node. Okay.
Name node. Once that is done, it will write the request to the FS data, sir.
FS data. Okay.
Once that is done, again the packages will be sent to the data nodes.
Data nodes. Yeah.
Once after completing of that, the request keeps on moving for the all the data nodes. I mean data
Exactly.
node 4 like that all,
Yeah.
and it will reverse back. Uh, that is
Data 6 is completed to data 4.
yeah.
So from
Yes,
here, it
yes,
will communication will go to here. Here communication will go to
yes.
here. Here
Yeah.
it will be like this in the reverse
Yes,
order.
yes,
Yeah.
yes.
Then
And then
it
it
will
will get,
confirm to. Hmm.
it will acknowledge from that,
Hmm.
from a data node to the
Hmm.
that is FS data.
Hmm.
Once that is done, it will close, sir.
Perfectly fine, perfectly fine. Yeah. Now, Veda or
Yes,
Deepthi? Thank you, Anisha. Thank you.
it's okay,
Now,
sir.
Veda or Deepthi, in your own words, just let me know what happening here. Veda or Deepthi? Anyone or Arun?
HDFS client
Hmm.
will ask the name node, like where to save the data, and
Okay.
then
Hmm.
um, the
What
name
name node
node
will do then? Yeah.
does not like it will not store the data by itself. So
Hmm.
um,
Okay. It will point to the location where it needs to save the data.
yeah, yeah. So the client will send
Hmm.
block A like
Hmm.
to the first data node,
Node. Okay.
and data node one will store the block at
Hmm.
and at the same time
Okay.
and forward it
Hmm.
like
No problem. Yeah, come on.
okay, and then um, data node 1 passes it to data node 4,
Yes. Yes.
and finally um the like data node 4 passes it to data node 6.
Yes. But before passing, just to correction,
Mm.
this client will ask name node where I should store my data. Fine. It will apply write request. The name node will give the IP addresses. I mean location where it should write the data. Or data node 1, data node 4, data node 6. Now this client will go to this data node 1 via this core switch. Okay. To store the data here. First, storing data is completed in data node 1. Then this data node 1 will send this package to the data node 4, and data node 4 will store the data here. Okay. Now this data node 4 will send that package or block K to the data node 6. Okay. Now data node 6 will store the data here. Okay. Now data node 6 will send that package is successfully stored, successfully saved. Now data 4 will send to the data node 1 that, hey, my package is saved successfully, and also data node 6 package is also saved successfully. Okay. Now data node 1 will tell to core switch that, hey, my package is stored successfully, and data node 4 and data node 6 package is also stored successfully. Now core switch will tell HDFS client that all packages are written successfully. Now this HDFS client will confirm name node that packages are written successfully. Okay.
Okay.
Okay. Fine. Now who is next? Come on. Karthik, Harun, um, Dipti. Dipti.
Yeah,
Yeah.
it's like
Hmm.
it's the client name node write a request,
Okay.
and the client HDFS client wants to write a block A.
Block A.
It
Yeah.
sends the request to the name node.
Name node.
Next, the name node does not store actual data.
Hmm.
Instead of it replies with the list of node data nodes,
Data
IP
node.
addresses,
Data node site address.
data node
Yeah.
1, 4, 6,
Hmm.
and client connects to the first data node.
Okay. Via core switch.
First,
Okay. Hmm.
yes, and the data node 1 connects to data node 4,
Before
and 4
connecting, before connecting, what it will do?
setup
No, it will store
pipeline.
the block A here.
Uh,
Then only it will
o-
connect to this data node 4.
okay,
Hmm. Continue.
fine.
Hmm.
Yeah, then data node connects to data node 4, and 4 connects to data node 6.
But before connecting, what they will do?
Mm,
First, they need to store the data, right? Each data node needs to
yes,
store the data. Then only it
yes,
can ask data node 4 to store the data.
yeah.
Similarly, data node 4, what data node 4 will do?
Mm, before connects to data node 6, you're asking.
Yeah, yeah.
Mm, let me see.
It will store the data first.
Okay.
Okay, then only it can ask data node 6 to store the data.
Okay. Okay.
Okay, now data node 6, once after completion of data storing, what data node 6 will do?
The data transfer.
Data transfer.
Block,
Okay,
yeah,
okay,
block A to data node 1,
okay,
and data node forwards the same block into data node 4,
okay, fine,
and it same forwards to data node 6.
okay.
The finally it is acknowledged.
It is acknowledged to data node 4 and
4
4 to
sends an acknowledged to data node 1
1, and then core switch, and then
to the client.
client node will confirm name node
Block A has been successfully written like that.
written in places. Then name node will save these addresses for block A.
Yes, yes.
Okay, fine, perfectly fine. Who else left? Arun and Karthik, right? Yeah, come on, Arun and Karthik. It's your turn now.
The HDFS client.
Hmm. Can you speak a bit little loud, Karthik or Arun? Who's speaking?
Yes, Kartik. Kartik.
Yeah, Karthik. Yeah.
Sir, HDFS client is to
Hmm.
write request to name node.
Name node.
So the name node is confirm
Hmm.
confirmed to send a request client node.
Hmm.
So after client node, its block is into core switch and data.
Hmm. Hmm.
So data node one store the data
Okay.
and ask to the data node 4.
Hmm.
Uh, if data node 4 is store the data and ask to the
Hmm.
data node 6.
Okay.
After
Okay.
data node 6 is to again transfer to data node
Hmm.
4
Hmm.
and data node 1.
Hmm.
So after data node 1 code switch and confirm to client node and client node is sent to name node.
Exactly. Now name node. What name node will do? Let's save the IP address, or what? It will not save.
It will save it.
It will save. Yes. Perfect. 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 Now Arun. Arun, come on.
So the client will choose the first data node, sir,
Okay.
and it will establish connection with name node.
Name node. Okay.
Yeah, the name node will send the request to core switch.
Okay. Directly
That
core switch or to client.
a client, sir.
Okay. Fine. Client.
The client will inform data node 1, sir,
Okay.
and it will receive block, sir, and then it will save in the data node 1,
Okay.
and the data node will switch to data node 4,
Okay.
and it will switch to data node 6, sir.
Okay.
At at last, the data node 1 will inform the client, sir,
Hmm.
and all these data nodes will be formed.
Successfully written.
Yeah,
Okay. Now name node
you
will
can
save these addresses for block A.
block it.
Okay. Now, cool, cool, cool. I really appreciate you guys. Super, super. So now
Can you
let's say
explain one more time? One more time, sir.
you want to explain or you want me to explain?
You explain one more time, sir.
Sure, sure, definitely. Now block A, right? See, this is a underlying mechanism, right? No one is never this like, mechanism with the human eyes. We are assuming this is how it's happening, and also they are claiming, these developers are claiming that this is how it happens. Maybe I mentioned this is client node is the one who is going to these places and writing, or someone will come and say name node will go and write into these places, will confirm to client that data is written successful, something like that. So it can be vice versa, but do not worry that. But just understand the core concept here. Okay, maybe someone will tell you that client will request name node. Okay, I'll just change small thing here. Client, the request is happen now, name node will get to know the addresses, data node addresses, and it will name node only will collect the data from here. It will go and ask this switch to this data node want to store the data, 4 and 6 to store the data. Then name node will know that okay, this data is stored here, and then it will confirm client that okay, your data is successfully stored. That's it, right? That can also happen, but it's up to the developers. Developers already developed it, and they has mentioned this is how it happens. So that's why we're assuming like this. If this is not the way, it could be the way. But yeah, don't confuse what you are thinking, right? That's perfectly all right. Now let me again go walk you through block A. Okay, client, this client, I'm Raviteja wanted to store 128 MB of file into HDFS storage. Fine. What I will do, I will client as a HDFS client, client node, client CVM, you can call it HDFS client. Why client node? Client node in the means my machine, my laptop, this laptop I will use to connect to name node. How I will connect to name node? I will have some username and password, some URL. Let's say, think in that way. So I have some URL. I will type that URL. Okay, I will enter some password. Okay, then I will connect to this name node. Fine, fine. I will ask them to store the data, like how you store the Google Drive. You will, if you open a Google Drive, right? Simple, Google Drive. Google Drive is in some remote server. I need to sign in. I will sign in. When once you sign in, then you will go and see the you will go and see the you will go and see you will go and connect to the name node. Okay. Now name node receive the block. Now name node will give you the IP addresses. My system, it will give the IP addresses of where I should store my block here. Now data node 1, data node 4, and data node 6. Okay, now this client, as my system only do the writing as well. My system will get access to this data node for a particular amount of time. It will directly go to this data node one. How it will go? Because let's say core switch, right? Think of it like your router, Wi-Fi router. Wi-Fi router will route your request to this location. Okay, there are some handshakes happen in the background. Okay, that's advanced concept or a small concept in networking, but yeah, there are some handshake happens in the between. It will try to establish connection with this switch or this server, whatever may be. It will go and write this data into this data node 1. Okay, fine. Or it would be either way. It will write the data, then it will try to connect to this data node 4 and write data here, connect to data node 6 and write data here. Or already the connections are already established, because as we mentioned earlier, these all the servers who are working together, right? All the slaves, these are slaves, right? Slaves are already internally connected. Okay, now as they are internally connected, they will update this. The file got stored here, then it will go and sit into this location data node 4. It will go and sit in data node 6. Now once this is done, data node 6 will tell data node 4, okay, successful, write is successful. Data node 4 will tell data node 1, write is successful. Now I will go and tell this system, right? It will tell that name node that, hey, my write is successful, thank you. What name node will do is, name node will save these addresses, because again, if I go and ask this name node, hey, where is my data, just give me the data, I want to do something, then it should give, right? How it will give? It's supposed to know where this data is located. That's why it will store these IP addresses. But before writing this data, if it stores this data, if something happens in the middle, there is no acknowledgement to name node, then what happens is this client will go to this name node and ask, where is my data? This name node will go and check in the location, because it was unable to write the data here. There is some issue happened, right? It was unable to write the data. It didn't even mention to name node. It completely silently exited. Now name node thought, okay, that is already saved, fine. But when client will unknowing, let's say the client is very bad, he will just go and ask this. I still go and ask this Google Drive, where is my data? Then Google Drive needs to go and check here, where is my data? Is there it already shows the addresses, right? IP addresses. It will go and check in the IP address, that is there a data? No, there is no data. Then it will go and check here. Oh, there is no data again. There is no data in data node 6 as well. Then it will think, okay, something happened, error found, something like that. It will throw some error. Okay, so that's how these things happen. Arun, hope you understand right now.
Yes, sir.
Okay, just again go through this thing. Step 1, write request. Step 2, IP addresses. Step 3, connect to core switch. Step 4, data node 1. Step 5, data node 4. Step 6, data node 6. Okay, now again from here the acknowledgement will come here and go back to name node. Name node will store. Now let's go to step node 6. HDFS, see, you already got to know, but it's just one more replication. HDFS write pipeline. Client will connect to give write request on DNA1, DNA4, DNA6. Core switch, to data node 1. Data node 1 will go to data node 4, 4 to data node 6, block A. Okay. Now block A replica to, I mean, what block A, right? This block A is the original block A. Now this is the replica 1, right? Because I mentioned, right, this is the original one and next will be the duplicates. This is the replica 1 and this is the replica 2. Okay, that's a replica's representation here in this diagram. Now acknowledgement, you already understand, right? From here, it starts from here. Step 1, data node 6 will acknowledge from data node 6 to data node 4. block A completed, copied. Okay. Now data node 4 will acknowledge to data node 1, block A copied. Okay. Now data node 1 will acknowledge to that core switch that block DNA 1, DNA 4, DNA 6, that block is completed. Blocks are completed. You will go into client node. Now client node will say write the successful name node. Metadata updated. So clear, right? Clear for you guys, right? Hmm?
Yes,
I
Yes,
sir.
wanted to hear. Again, after this class, I would really request you to just go through this concept, okay? Then
Yes,
you
yes. Okay,
now
sure.
read operation. No read operation. How read operation happens? Can anyone just tell me how read operation happens? But before going to read operation, let's see how two blocks can be written. How two blocks can be written? Can anyone tell me how two blocks can be written here? Simple. It's very simple. Just two blocks. How two blocks can be written?
In HDFS, sir,
In HDFS, how two blocks can be written?
the first will be
Hmm.
the distributed one, and second
Hmm.
file system. Two.
Sorry. Two blocks. I
You're
mean,
asking. Uh,
here you have block A, right? What if I have
yes.
block B as well here?
B. Okay.
It will split, sir.
The same process, no, sir.
Same process.
128, 120.
It will split. It will, after splitting, client will never give I have two blocks. Name node will tell actually you wanted to write 256 MB of data. That means you have two blocks. Client name node
Maybe
will
it
tell
can
client.
go directly to the core switch, sir, if possible.
No, it will never go to
No.
core switch because it won't interact with this data nodes. It will directly interact with name node. Name node needs to
Okay.
give permission to this client. Okay, and
Okay,
name
sir.
node will tell because this client node will never know these nodes. They are very anonymous to this client node. Only this name node knows this because all these things are working together. Name node will never do that. Name node will never do this. All these are working together, and this is never. This is a separate. This is a third party. This is very foreign to this system. Okay, so
Okay, sir.
okay, yeah. Now, what happens is block A, block B, then it will go and ask this name node, hey, I have two blocks. I mean, it will just ask this block name node that, okay, I want to write a request. Then what name node will do is name node will take both the blocks and just give six addresses. Why six addresses? One block you have three addresses, but for two blocks, why you are having six addresses? Okay.
1 plus 1, 2, 3 plus 3.
3 plus 3 6 exactly, because every block you need to replicate three times, right? Not the one time. One block you're replicating three times. Now second block also came into the picture. That means you need to replicate three times, another three times. That means you need to have six IP addresses. Now what this name node will give is, for block 8 will give DNA1, DNA4, DNA6. Okay, assume IP addresses of DNA1, DNA4, DN6. Okay, for block B it will give, let's say, DN2, DN5 and DN7. It can happen, right? We'll just here it just gave. Now for block B, right, you have a block B. This is B. Okay, for block B it will give DN, what are the missing one? DN2. Okay, and DN, let's say DN
7.
7, let's say, anything. And never, it doesn't mean it will give you only the new nodes. It can give you the same nodes as well. It can again give you the DN what one as well. Again, it can happen because different blocks can come and sit into the same switch. That can happen. Okay, it will never do that. Okay, it never have that partiality. It just make sure that this blocks will return, will sit in different places, so that whenever one switch is gone away, the other two switches still have the data. That's it. Okay, it will never replicate three blocks. I mean, three it will never replicate that three blocks, this data node 1, data node 4 and data node 6, three blocks, right? The same three replicas in the same box, same switch. Okay, why we want to do that? You upload some file, right? Your file will never be stored in the same server. All entered two duplicates and the one original file, right? These three replicates will never store in the same server, because if that server goes down, then entire your data is gone. That's it. Will make sure that this data sit in the different servers around the world. Okay, so for clear.
Sir, if
Yes,
we
sir.
give same
Yes.
data node, duplication will not happen, sir.
Data node.
Sir, if we give data node same 1 1,
Hmm.
duplication will happen, no, sir.
Duplication. Why duplication will happen? I mean, how you are giving data to no data node one block, both block A and block B to data node one.
Yeah, so two blocks, block A, block B.
Hmm.
If we give data node one and same 1 1 same, it will become duplication, no, sir.
No, it won't have duplication. Why it will have duplication? Block A is a different block. This is a different block. This is a different block. Block B is different. Block A is different. It will never have the duplication. The duplication will store in the data node 4. It's block A's duplication. And block B's duplication can store in data node 4 and data node 6. That can also happen. It will never get duplicated here. Okay.
Okay.
If any confusion or anything, just try to watch out this, because what you're doing to do, block A should be represented data node 1, then data node 4, data node 6, successfully written, fine. Now block B will come and sit in data node 1, okay, and data node 4, data node 6, no issues. Why there is no issue? If block this, let's say block A, right, its first represent is in data node 1 and second is also in data node 1, third is also in data node 1, then it's an issue. If suddenly this data node goes out, this is a system, right, suddenly it goes out, it shut down, then that's an issue, right? That's why we will take this, we won't store the duplicates here, we will take this duplicate and put it into different data nodes. Okay.
Okay, sir.
Yeah, Arun, you still have any doubt? You can just reach out to me. I
Okay,
will
okay.
answer that. Okay. Just acknowledgement also. You also know how this acknowledgement happens. Fine. Read operation. Finally, read operation. If a read request comes from this right, this client, right, this I will ask my Google Drive. Hey, I need to access my data. Then what it will do? It will just take this name node. Name. It will go to connect to my name node. Name node will give the IP addresses of DN1 and DN3. Why DN1 and DN3? Why it's not giving all the addresses? Can you just let me know?
So it's just giving address of block A.
Block A, because one location is enough, right? Why I should give three
Yes.
blocks, three locations? In the all three locations, it's the same file. Then I can just give the one location details. That's it, right? It will go and fetch the data from there. If the data is not present here, then I will give second location name. If it's still not present here, I go third location name. Right? Very simple. Why would I give all three locations? No need, right? No point of giving all three locations will contain the same data. Same duplication, right? Understand?
Yes, sir. Yes,
Yeah,
yes.
yeah, yeah. Perfect. So, for any doubts in this read and write operations, now we need to start next class on this map reduce. Map reduce you're already aware, but yeah, just some technical theory. Okay. So, any doubts in read and write? Any doubts so far?
No, sir.
No,
No.
sir.
Perfectly fine. Perfectly fine. Tomorrow, let's. I want you to again in the starting of the class. I want you to explain what is this data read and write operations. Okay.
Okay, sir.
Okay.
Okay. Now let's start MapReduce. Fine. MapReduce. What is MapReduce? Can anyone tell me? Just plain words. Never. I never want you to answer any technical words. I want you to answer any plain words, ordinary terms. Okay. Just tell me what you understand from MapReduce.
MapReduce is a framework.
Sir, it will map the data, sir.
Map the data. First thing, when someone asks you MapReduce, what is MapReduce? You can say that MapReduce is the processing component of Hadoop. Okay, you already know that. That's why
Yes, sir.
I always want you to read this file after PDF after the class. If you see here, where is this? See, MapReduce is the processing component of Hadoop, which provides a software framework for writing applications that process large amounts of data. You don't need to remember all these things. Just MapReduce is processing component of Hadoop. First thing. Then for processing large amounts of data in parallel. What is MapReduce? MapReduce is processing component of Hadoop and helps to process large amounts of data in parallel. That's it. Then you can go to this thing. MapReduce operations are divided into two stages. One is map stage, reduce stage. Okay. Okay. Now tell me what is
Yes.
MapReduce?
MapReduce is the
Hmm.
processing component of Hadoop.
Hadoop. Okay.
It is a software framework,
Okay.
and MapReduce operations are related to
Software framework for
writing applications.
writing application. Which applications you will write? You ignore that writing application. Just remember that software framework to process large amount of data in parallel. Okay. Software framework to process large amount of data in parallel. Okay. Just remember that.
Okay, sir.
See, MapReduce is a programming framework that allows us to perform distributed and parallel processing on large datasets in a distributed environment. Simple. Perform distributed and parallel processing on large datasets in a distributed environment. Okay, perfect. Now, map reduce consists of two distinct tasks: map and reduce. Okay, you already got to know what is map and reduce. If map means if I give you a task to name node will divide those tasks into five stages, five persons, right? It will divide the task into five because I told you the six laptops concept, right? It will divide that into five because I have five laptops. Now what I will do, I will give five tasks to all you people. Then what happens? First, I need to map. Okay, I will give you the first five pages of PDF, this entire PDF to one person. Second five to one person. Third five to one person. Last five to one person. Like that. Then you need to count number of votes in that PDF. You will count those numbers. Then now mapping is completed because I mapped the task to you guys. Okay. Now this output you calculated. Okay, I told you how to calculate. Hey, this map reduce, right? After this there is a space, that means this map reduce is first word, then E is second word, A is third word, like that you somehow calculated it. Now you need to give output to the name node. Now name node will reduce, take all your outputs and combine all the results and form a final output. That is the answer of your number of words in this PDF, right? That's what map reduce is. Now let's go one by one. MapReduce consists of two distinct tasks, map and reduce, which we just discussed. Map means mapping tasks to the nodes, and reduce means just taking the output from the nodes and just combining the result. Okay. As the name MapReduce suggests, reducer phase takes place after the mapper phase has been completed. It's self-explanatory, right? Because you cannot reduce the you cannot combine the results before even it's calculated. Well, before you first you need to map the task, then only you can expect the results from them. Without mapping, how can you expect the results? No, right? That's a mapper phase will happen first, then reducer phase will happen, takes place. Okay, so for clear. Now the first the first is map job, where a block of data is read and processed to produce key value pairs as the intermediate outputs. I just mentioned, right? Key value pairs. What is key value pairs? Let's see. The first is the map job. Map job. In the map reduce, that means first is the mapper job. Okay. I already mapped this task to each one. Now they need to run this mapper phase, where a block of data is read and processed to produce key value pairs. Key value pairs as intermediate outputs. Now this output of a mapper or map job is input to reducer phase, right? This output, right? Output of your mapper job or output of, because I gave weather or task. Okay, weather just calculate out of these five PDFs, right? Just calculate how many number of votes are there. Then weather will do that and just give that output as input to the reducer job, right? Now this output of mapper or map job is input to the reducer phase. Fine. Now the reducer receives this key value pairs. Key value pairs, I will let you know what is key value pair. It's a different concept, so that's why. Now this reducer receives the key value pair from multiple map jobs, because you all gave your outputs to us, right? That output is input to this reducer. Then reducer aggregates those intermediate data tuples. Tuples in the sense, again, key value pairs. Don't worry about that. Into a smaller set of tuples, again key value pairs, which is the final output. Okay. Any doubts here? Other than key value pairs, any doubts here? How things happening? No,
Wow.
if you say nothing, then I think it's
No,
very well
sir.
understood.
No,
No?
no doubts. No doubts.
Fine. Super. Now let's say key value pairs. I'm just mentioning key value pairs. In the example I just gave you, right, there is no key value pairs. But key value pairs where it will come is, I asked you guys to calculate number of votes. What if I ask you to calculate frequency of votes? You know frequency of votes? That means I'll show you. Let's say calculate frequency of votes, or I'll show you a small example. Yeah, let's say this. This is input. Okay, fish swims in the sea. Big fish eats small fish. Red sea has red fish. This is the input. Okay. Now I need to I need to calculate I need to calculate the frequency of this words. Fish is repeated one, swim is one time, in is one time, die is one time, see is one time. Now big is one time, fish is two times, eat one time, small is one time. Here red is two times, see one time, hash one time, fish one time. Because my task here is to just calculate frequency of these words. Okay. You know frequency of words? Now you understand what is the frequency of words? Number of times the
Number
word is
of time
repeated.
repetitions.
Number of times the word is repeated. Fine. Now I just map. So this is your input, right? This is your input. Okay. This input, right? This is single output only. This fish swim to here, right? This is single output only. But I need to divide into blocks, right? I need to divide into blocks definitely. You know, right? Because whenever I give data, maybe here it's small amount of data, but in real world, let's say you give some 128 MB plus 128 MB plus 128 MB. How much? Let's say some 512 MB or something. Then you this HDFS will divide that into how many blocks? Will divide into as per 128 MB block is equal to 4 blocks, right? Here it just got 3 blocks only, 3 blocks. Now each block is given to each map job. I mean each node. I mean there are only 3 people. So I divided my task into, I splitted my data into 3 parts. First part, second part, and third. I told you an example yesterday, right? There is a 120 GB file that will be divided into 20 GB, 20 GB, 20 GB, 20 GB. And also we discussed, right? There are 25 pages in this PDF. 25 pages in this PDF. I will give 5 pages each to you. Right? Similarly, here you think like this is a small data. This is divided into 3 parts. What's first part, second part, third part? It is mapped to some node. Fine. Map to some node, map to some node, mapped. Now mapper will run first, right? Mapper will run. That means fish mapper will run. Mapping is done. Now it will map to this fish comma one, sims comma one, in comma one. So that frequency. Now big one, fish two eats two, small two. Similarly here. Now intermediate result. Intermediate result is there. Now why we are doing shuffle and sort here? Why? Because I have a fish one here, fish two here, fish one here. Okay. So before giving this result to this reducer phase, I will do this shuffle sort. That means this fish will go to fish. All the fish related data will go to one place. All swims related data go to one place. In will go to one place. D will go to one place. Big. So let's say fish will go here. Okay. Swim will go here. Okay. Now in will go here. The will go here. Fine. Now big will go here. Fine. Fish will again go here, because fish cannot go here because already one fish is here, right? All the fish related data should be in one place. Now eats will go, which will it should go. I think eats should go here. Okay. Now small will go here. Now red will go here. C will go here. Fish cannot go here because fish should be here, and has will go here. Now we are doing some shuffle and sort, because we just wanted to, because you got fish one time, fish two times here, and fish one time here. That means in total fish is repeated 4 times, right? Fish is repeated 4 times, but fish is here is one fish, here is two fishes, here is three fishes, right? If you wanted to calculate that fish is four, then you need to sort this in such a way that all this fish related data will come into one place, and big related data come into one place, each data will come into one place. Okay. Now it will go to reducer will take this result. Reducer will take this. There are two reducers here. I mentioned only one reducer, but in real time One reducer cannot process it, then you can have multiple reducers. In this case, two reducers. Okay, they will take these two reducers, and this final output will be given to the users. Okay, now I know class is being extended. Just be sparing just 10 minutes. Okay, I'll just show you how this is happen in the real time. Okay, just a small example. Okay, let's take small example. Okay, good, good, bad. Okay, small example. Let's take very small example. Okay, now again average, AVG, good, bad. Okay, this is your output. Sorry, input. Bad, average, bad. Okay, now I'll show you like how input will be is input is equal to good comma, good comma, bad comma, average comma, good comma, bad comma, bad comma, average comma, bad. This is the input. This is a single block. This is input file. Okay, fine. So far clear. So far clear. Hope.
Yes, yes.
Yes, sir. Yes.
Okay. This is the input. This input is divided into three blocks. Okay. Input is splitted into three blocks. Okay. Three blocks. Now I need to go mapping phase. What is the mapping phase? This is the mapping phase. Map one. Now I need to do mapping. Good comma one. Okay. Now
So we have twice, no, sir. Good.
we have ties, but we won't do it right away. We will do
Okay.
it
Okay.
good comma. We will do it in one by one. So first we need to map some values to the counter, right? We are just mapping that counter here. Good. Sorry, bad, right?
Okay.
Bad, comma one. Fine. Okay. Now let's take this map. Average, comma one. This is tuple, right? You know tuple how tuple will be represented in Python. Good, comma one. Bad, comma one. So for clear, this is map. Now this is also map. Bad, comma one. Okay. Average, comma one. Bad, comma one. Fine. This is mapping, right? I just mapped to this here, and this here, and this here. So this should be like this. Okay, mapping is done. Now I need to do one more phase here. Just count. Now I need to count. Now I want you all of you to unmute and tell me how many goods here.
Two.
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 Two. Now bad.
One.
One.
One. Okay, fine, cool. Let's go here. How many averages? How many good? How many bad here?
All
One.
one. One.
One.
One.
All one one. Let's
Yes.
copy this and paste it. Fine. Now let's go here. Now tell me how many bad here.
Bad
Two.
two. Average.
Bad
Two
2,
bad. Two. Average one.
Bad
average
two,
1.
average one. Okay. Fine. 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 Super. Till here, super. This is the next phase. Okay. Now I need to calculate the count, right? Wait. What is this? Now I need to do some shuffle short here. Why? Because some shuffle shorting here. Why? Because here I have good, here I have good, here I have bad, here I have bad, here I have bad. I need to put it into some different phases, right? Now what happens here is if you go and see this uh, diagram, right? If you see here, where is this? See, shuffle sort will sort the data in such a way that all related data will sit in one place, one place. Okay. Now let's take two. Okay, let's take two. Let's say shuffle short. Okay, this good, let's say this good. Okay, this good will go and sit into this one. Okay, this bad will go and sit here. This shuffle will take care of that where it should sit. Now this average will go and sit in this place. Now you tell me where this good will go and sit.
Left
Left
hand.
side what?
Left
Left
hand
side.
side.
Left
Left.
hand.
Left hand side. Perfect. Left hand side. Now bad.
Right
Right.
hand.
Right. What happened? No bad one. We done right? Good two, bad one. Good two, bad one. Average one. Good one, bad one. Okay. Now bad two and average two. Where this bad two will go and sit.
Right.
Right.
Right side.
Right. Okay. Now this average one.
Right side.
Right.
Right side. Perfect. Average one. Perfectly fine. Okay. So you can make the arrows here something like this. Okay. Because this output, right? This output is input to this reducer phase. For your information, this is the reduce phase. Okay. So now what happens here is now it will take good. Now how many number of goods here?
Three.
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 Now the how many number good and averages here?
Bad we have four, and average two.
Four.
Four. Fine.
Average two.
Average two.
Average
Average two.
two. Okay. Now where reducing happened? Where your output is finally calculated. Now this is the output. The this is the input. Okay. This is the input. This is the final output. The good three, bad four, average two. Okay. That's what we gave input to here. So what happened here? First what happened here? What is this stage? Splitting.
Splitting of the three
Splitting of
blocks.
three
Splitting of the
blocks.
data. The data is split. Now it got mapped. It got
Mapped.
mapped, right? Map phase. Mapper has run. The mapper has created some mapping. Let's say for a good one, good bad one. So mapping has created for because it's a one value. I just give one. Now just mapper has done one more mapping that good to bad one, average one, good one, bad to average two. Fine. Mapper has done. Now what happened here? It
Shuffling
again
sort.
shuffling sort has happened. Why shuffle sort happens? Because we wanted to calculate these values, good values, bad values, and average values. But if you observe here, in this place there is one good, in this place there is one good, in this place there is no good. That means the good is in one place and good is in one more place. I need to put it into same block so that I can calculate same function or same place, right? I can calculate. You see, there is some data, right? That data should be in the same place. Then only you can calculate that value, exact value. Right? If good is in two here and good will come one here, let's say if you put this good one here, that means you will see bad four average to good one. Here you see good two only, but actually good is four. Good is three. That's why we should do some shuffle and sort. That means this good value will sit in one place, bad and average values will sit in one place. We done that. Now, this is what reducing phase is like. You gave your output. This is our output, right? This is your output. Actually, good one, bad one is not your output. Good to two, bad one is your output of this mapper phase, right? because you need to give the final, you need to do local calculation, right? Then this is the final value, you just gave it here. Shuffle shot is gave it to this good 2 and this here. Now you just gave that good 3 and bad 4 and average 2 as an output here. Okay, now this is the output. Okay, good 3, bad 4, average 2. That's the output. That's the output you will showcase to the users. Okay, so far clear? Any doubts in this diagram?
Yes.
No, sir.
Yeah.
Fine, perfectly fine. See, this is how this happens. Input, okay, input, splitting, then mapping phases, then reduce phases. But here, shuffle short happens. Shuffle short happens. Then again here you need to combine the result, right? It's in I mentioned, right? I will give you task and you will give that output to only me. But what if you give output to Subhashri as well? Then Subhashri also needs to me and Subhashri needs to give my output to Akhil, or someone who is superior to us, right? Someone I need to give my output, right? Okay, so you understand this diagram. Input phase, you will give you I gave you the task to you, map task. Then using the shuffle sort, I just sorted the shuffle the result to two different places, two different let's say, let's go here and see two different places. This good went here, bad went here. Or see, you might have thinking that why we have gone with only two. You can go with one also. Okay, just remove it. Just remove this. See, only one face here. You can also go with one as well. One as well. But it's just that I gone with two. Okay? Minimum two, if it's best, one is lagging or one is lagging behind, something like that. So I just gone with two. Okay? Similarly, here I gone with two. Here also you can have one. And finally, you will aggregate the results between these two and just give it to the output. Okay? So far clear. Similarly, here as well. Input chunk 1, chunk input split 1, split 2, split 3, mapping. Then the intermediate result is swapped, shuffle short. Okay, then this result is here. Okay, now what happens here? This map reduce you already understand. This diagram you understand. Hope you understand. This input chunk is also understandable. Okay, now let's go and see what's happening here. That's it, word count problem. And tomorrow class I will continue this word count problem. You already know this word count problem, okay? But I will just do that. See, if you see input data on stored on HDFS, input format, based on input format we do input split you already see, right? Here I will ask you one more thing. Here good, right? Here good, right? This good, right? I just gone with good bad, but somehow I gone with like this. What happens? Let me show you. Let me show you. This is one block. Okay, I just gave you bad here. This is one more split. Okay, if you clearly observe, I just made this bad two different words, right? If you see here, BA and here and D here. Is this correct? I want an answer.
Yes, sir.
Is this correct? I just make this bad into two different words. It should never happen. If this happens, then it will all together it will give a wrong output, because it will calculate BA as one word, D as one word, right? But actually it's not that case. So that's why input split is intelligent split. That means it will aware of that. The system will aware of that. Okay, this is not the way. I will split only after this, let's say comma. Only after the comma it will split. See, if you see, only after the comma it's splitted, right? It is an intelligent split. It will know how to split. Okay, based on that it will split. Input split, then it will record reader. Okay, so if you observe here, record reader, this is a record reader. So I just take the record and read it. I can read it. Now I just mapping or whatever you call it as, just calculation. Now mapper. Now it will create intermediate key value pair. Now combiner. Okay, now combiner in the sense, like if you see here, I just combined here. This is a mapper. Here I just combined. Okay, now let's go here. Partitioner. Okay, partition in the sense that right, how I partition, how I shuffle, and all those things. Partitioner. Now reducer, output formula, output database. Okay. Now tomorrow again I'm going to explain this. Do not worry. But I just want you to just go through this document again and just see how things happen, because for your information, you already are aware of all this concept except this yarn, right? Except this yarn, everything is all you are already aware of it. Okay, except yarn. Just leave it yarn. Tomorrow we will cover yarn. Definitely. Tomorrow we will try to wrap up this yarn and map reduce. Okay. Maybe we'll extend the class maybe on half an hour or so. We will cover that Thursday and Sunday, Friday's class. We will cover that as well. But yeah, just go through this document again and you will understand. Okay. Super clear. Any doubts?
No, it's just clear.
Okay. I want you to everyone to read this document. Then only you will have it doubts. Then only I can clarify you. If you do not read this document, you will never have doubts. I can never clarify those doubts. Just get doubts. Just read something. If you read something new, you should get some doubts. Then only we can like people like me can address your doubts. Okay. See, advantage of map reduce. In map reduce, we are dividing job among multiple nodes, right? Multiple nodes, because all these are data nodes. If you observe here, all these are data nodes. All these are data nodes. Data node 1, data node 2, data node 3. Data node can also process the data, not only store the data. So multiple nodes. Each node works with a part of job simultaneously. Just small part of the work, right? MapReduce is based on divide and conquer. We divided and conquered, right? Which helps us to process data different machines very quickly. Now data locality. Instead of moving data to the processing unit, right? We are moving the processing unit to the data, because how here I will write in real time. I will write a code to calculate this logic. Okay, some code. That code will be given to this data node. Hey, data node, you need to run. I already gave the data to you, small amount of data to you. Take the data and take this program as well. Just run this program on top of the data. That's it. The data program is also will be sent to the data node. Okay, as the data grew, used to bring data to the processing unit and process it. Actually, in the traditional system, we used to bring the data to the processing unit and process it. But as the data grew, it becomes very huge. Bringing this huge amount of data to the processing unit has the following issues. Moving huge amount of data is costly, deteriorates network performance. There are single unit which becomes a bottleneck. Master node can get overburdened and may fail. These are the issues we faced. Okay, just now go. Now MapReduce allows us to overcome the above issues by bringing processing unit to the data. Now, see, it's very cost effective to move processing unit to the data. The processing time is reduced for as all nodes are working with their part, right? All nodes are working together, right? Working with separate amount of data, right? Now every node gets a part of process, and therefore there is no chance of node getting overburdened. We just divided task in such a way that no node will get overburdened. We split it in such a way. Now this is the traditional approach. This data is moved from data is stored here in the slave nodes. Data is moved to master, and master used to process the data and give the result. Here data is here itself. I just gave the code to each one, and then they processed it. Okay, now this is famous word count problem. Input, splitting, mapping, shuffling, reducing, final result. Okay, now map reduce data flow. How is map reduce data flow? You can understand what is input files. Okay, it's a kind of input file, input format. Based on input format, it will create a input split. Okay, now record reader and all these things you can just go through. It communicates input split to Hadoop MapReduce, converts the data into key value pairs suitable for reading by the mapper. Now it processes each input record from record reader, generates new key value pair, and this key value pair generated by mapper is completely different from the input pair. Okay, just combine the next it will combine the results and give it to the reducer phase. Okay, now we will do the shuffle sorting. What is shuffle sorting? You already know how it will be shuffled. Okay, now the reducer will reduce it. Now record writer, because we need to write into some location, right? Output file location, then that will be written into record writer. Then output format, how the output should be written, it should be written here. That's it. Again, just a difference, input split and block. Okay, so block means you already know. Block 1 means 128 MB, block 2 means 128 MB. But input split means how happens here is it will be given in. I show you an example, right? Bad, how bad is divided. BA to one split and D to one block, right? That's an issue. We should never do that. We should put this entire BAD into one block, either left side block or right side block. That's how we design. Right? Input split is a logical division. A block is a physical division. Okay. The purpose of input split is to control the parallelism of a MapReduce. Block is to optimize discrete performance. All these things. Input splitting depends on input format. All these things. Okay. Now you already know what is before 2012. This user could write MapReduce program using scripting languages before, but since 2012, users could work on multiple processing models in addition to MapReduce. See, this is the new approach here. This is the old approach, HDFS, MapReduce, and Yarn as well. But here, MapReduce, Spark. In place of MapReduce, you can use Spark on Storm or Yarn and HDFS, which I already showed you earlier. If you remember here, is this? If you remember here, I just mentioned that HDFS, Yarn is fine; they are still there. But Hadoop, in place of Hadoop MapReduce, we have a Spark here, PySpark. That's what these guys are telling here. PySpark. You can use MapReduce, you can use PySpark. To use MapReduce, you need Java. To use Spark, you can go with PySpark or Scala. Okay. Yarn, I will completely ignore this yarn part, but that doesn't mean you shouldn't read it. Just go through this thing one time, and you will have so many doubts. Then when I told you about yarn, right, you will clear most of the doubts. Okay. I know I'm going fast because anyway tomorrow I'm going to again start from here word count problem again. I will just repeat that problem. Okay. Yeah, that's it. Just go through this document. Okay, just go through this document. You will clear most of your doubts. In case you stuck somewhere, just go and google it. That's it. Still you unable to find it, just let me know. I will answer your question. Okay. Yeah, it's very late, I know, but yeah, thank you. Now let me know in case of any doubts. I'm stop sharing. Yeah, Veda, Arun, Karthik, Deepti, Anusha, any doubts?
So you can share PDF to WhatsApp group, sir.
I already shared. Okay, okay, I will share in the WhatsApp group as well. Fine.
Yes, yes.
You can then use that. Okay. Yeah, fine.
We can't
Any-
take download fully, sir, in app. That's why.
Okay, okay. Yeah, I understood that. Someone is mentioning in the call. Okay, okay. Yeah, I will share documents in the WhatsApp. You can download from there. Okay. Yeah, fine. Any other doubts?
No doubts.
Okay. Okay. Thank you.
Sir,
Um, yeah, Veda.
morning sessions is difficult for me, sir,
Okay, okay.
because
Hmm.
if I leave home at 8 o'clock, I will reach there at 9. Sharp 9, I have to punch, or else it will be LOP for me.
Acha. Okay, 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 okay. Fine, fine.
And
Okay.
I can't adjust that time. So at least 7:30 I need to get ready.
7:30. Okay, okay, okay.
Yeah. And if you like night,
Hmm.
how, like, what are the possibilities of 8:15 classes?
Actually, I wanted to plan every day 8:15 classes, but the thing here is, sometimes, right? Sometimes I will have my client